Okay. So now, in order to make a curve uh, like this, then you can go to here, use cover curve, and enter. Okay, then press enter. It will come like this. You can like make a triangle or whatever it may be. Then you want to select the material, whichever material you want. You can just select here. Then click OK. Click OK. Okay. Okay. So same thing. Triangle underscore one. Let's say. Okay. Now you might have seen this curve. Okay. Now you want to thicken that sheet, right? You can go to shape tools, uh, shell, or sheet. You can just give, for example, 0.035 or also. Okay. You can just see here. Okay. Now two triangles are formed. So if you want, you can just make it, or what you can do is you can just just made two triangles. You can just use transform, for example, transform or translate or mirror kind of thing. Okay. Mirror. You can use anything. Okay. For example, you can just make it as 180. It will come like this. Okay. Then you can move this all the shapes to wherever you want to fit. For example, using transform function. Using translate, for example, you can just move mostly in Z only because your patch is sitting in the XY plane, so it will be moving. For example, 0.035 and so on. Whatever thickness you have, you will just move it. That's it. Okay.
About the substrate,
Ye-
like
yes. You can put whatever substrate thickness, and then you can just move and ensure that it is there is no gap between the substrate and the things. Yeah, that's it. Yeah, can you show me that paper? So what is the difference you are having?
the people.
I'm able to see only the CST.
In between, sir, are you able to see it?
Okay, this is something we have to subtract from the patch, right?
Yes.
Okay, can you go back to CST? Okay, please let me check. Zero point 0.112, 0.006. 0.11 is the substrate thickness.
Right. Subsystem. Yes, sir.
Okay, well, you are mentioned thickness as 0.006. So on what basis?
Sir, it is mentioned in the paper.
Oh, okay. No problem. So 0.11 plus 0.006. Okay. Now, what we can do is like this triangle, right? Hmm. We can change the thicken sheet to 0.006.
Yes.
Is it 0 point? Ah, okay. Now we have to move that to similarly the triangle one. Now the other two will follow automatically.
Mm.
Okay.
Yes.
So now we will move this one to 0.1.
0.1.
Yeah, come
Yes.
like this. No. And how you have to subtract this.
Yes.
So solid, then you can go to Boolean, Boolean subtract.
Okay.
You can select all these triangles.
Mm.
That's it.
Mm.
You can see like this. Then you have to draw this other triangle, whatever shown in the paper, right? Within this one, using line or curve. Curve is better basically. You can just draw whatever you want.
Sir, but there's no option of triangle.
It is there, but it's a different triangle. Because I here you like this, right?
Mm. Yes.
Or what we can do is you can just draw a triangle, another triangle, then subtract it. That is also possible. Uh, Let me check. Maybe uh, if you want to draw a triangle, uh, mm, okay, 0.11. Radius, we can just adjust bottom radius, let's say. Bottom radius, let's say 5. Oh, no, no, no. No. It's, uh, but instead, curve is easy, basically.
Mm.
Let me check the cylinder. Yeah, curve is better.
Mhm. Sir.
Yeah. So you can use polygon, okay?
Okay.
Instead of curve, you can use polygon also. Let's say first you can just draw. If you enter, that's it. Okay. You can just adjust these values, okay?
Mhm. Mm.
Wherever you want. Oh, this is the one polygon. You can just delete these things. Otherwise, it will create a simulation error. Okay, like this you have right. Now you can just use the cover curve. Oh, you click on the enter. You can just make a V structure like this. As usual, it will be sitting on the bottom.
Mm. Yes.
Yeah, you can just first you can just thicken the sheet using shape tools. Uh, let's say 0.006. Now you can move to
0.11.
yeah, that's it. It has come down. like this. Now you can adjust this point
Mm.
where that's it.
Yes.
Yeah. Any other
Transform
doubt you have?
transform it to the all the time.
Yeah, yeah. You can do it. If you have any comments, let me know. Okay. Will help.
Yes, sir. Uh,
Thank you.
Sir, how to put the lumped element like vector diode in between this?
See, if you want to put simple number, right?
Yes.
Okay, you can go to simulation. Mm, simulation, it's not going. Can you click on simulation? Yeah. Okay. Hmm. You can see here lumped element. Okay. If you want to do lumped element, right? Simple lumped element, you can just choose, for example, which is serial you want, or diode, or whatever it may be. Okay. Here you have to give all the characteristics. Okay.
Mm,
What do you want to give? Okay. It's, I think, simple diode. So 50 ohm and so on. Okay.
mm,
And you have to give coordinates of this. Okay.
okay.
What you can do is before you go for that, let's say, so between these 2 points you have to give. You can just use M, means pick points. So you can just here there are number of options you can just pick. If you want to pick edge center, this is the edge. If you want to pick center, then you can use M. End point, then you can use P, and then face and so on. Okay, these are all the options. Once you select the peak, then you can just go for this lumped element. Okay, then you can just give, for example, whatever value you want to give. For example, it's just RLC serial means it will just, if you just give value of 1 ohm, then it will be just acting as a resistor.
Mm,
Or if you want to have a diode, then you can just use. I think this option I have not used, but you can just import the spice circuit file as well. Okay. For example, you can model the Variator diode in the other spice circuit. Then you can just import that model. That is also possible. Okay. Then diode. Hmm, you can give just, for example, whatever you want. You can just preview like this. It will
mhm,
come. Okay. If you want to invert a direction, right, you can just you can see here
mhm,
like this. Okay,
mhm,
invert direction. Then then click OK. Okay. If you want to modify any parameter that you want later, this is one option. Okay. The
mhm,
second option is you can just use schematic. Okay. Here we have to select the port, which port between which port where it's uh, though I have not used it, but you can just diode is there and all these parameters are there. Uh, you have to connect it to wherever you want. Like for example, drag and drop. Uh, you can just import any model that you want. Same thing, but it will be a kind of, you can see here. Uh, Either you import from file or, for example, pspice or whatever it may be. You can just import it.
mhm.
Better to use both options, like any option that you want. For example, port or whatever it may be. Lot of number of options are available. Like this,
Mhm. Right.
like this. You just map it. Okay. But
Mhm,
this is should be a little bit careful because maybe you can go through any existing examples. You can here you can just go through existing examples also. Computer libraries. Okay, here you can just explore some of the libraries or some options in the examples, and then use it properly. Basically, okay, yeah, that is the my advice. Actually, okay, currently you can just try this one. For example, if you want to try, instead of using diode, for example, if you want to try on and off, for example, on and off, okay,
mhm.
on means just shorting these two, okay,
Yes, sir.
off means just open, leave it open, right,
Mm,
okay. So in that case, what you can do is just to use a strip also.
Mm.
That is also workable. Okay.
Yes, sir, in
Th-
your previous videos, I
Yeah,
have.
yeah.
Yes,
Just
sir.
use a strip and then connect it. Then you just remove the strip. That is also possible. Okay.
Mm.
See, essentially what you're doing on the on condition, it will become a short circuit. Off condition, it will become an open circuit. That's it.
Sir, basically what the paper says is, according to the different values of this, for example, C max, C register, C minimum,
Yeah.
different values, it will plot the graph as parameter graph.
The thing is, it's very easy. Actually. Mm, you can go back to CST.
Yes, sir.
You are having this diode, right? You can just go here. Here, instead of value, you just define a parameter like this. Okay.
Okay.
And make sure that this value, see, the thing is, they might have given microfarad, right? Here it is in farad. You have to convert that.
Okay.
Okay. Um, then you can just go to here, home, parameter sweep. Okay. You can just go new sequence, new parameter, capacitor, right? You can just sweep whatever the value.
Okay.
In steps of what? Number of samples you can just use, or you can use step width to control this. Yeah.
Okay. Yes.
Anything else?
Uh, mm, mm. I will place the diode at its accurate position and
Yeah.
then sweep and finding the experiment. Okay.
Yeah. 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 Okay.
Sir, other than this all can draw in the CST as well. Can you see the paper, sir?
Yeah. 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 See, on the left one, right? Can you open any simulated file?
Have the knowledge.
Maybe you can just, I will just, can you open the CST? I'll
Yes.
just show you. Hmm. Let's say this one. Oh, this does not contain the 3D field results. Okay. Mhm. Hmm. Okay. Let's take this. Yeah. Let's say this is the, so this is a polar plot. Okay. You can just go to 1D plot. Can you click on the 1D plot? Oh, Here you can just choose. Oh, far field should be there. Yeah, here, Cartesian. Okay, this is the plot. Right. If you want to control, like it is in 0 to 360 format, right? You can go to far field properties. Okay, then you can just use plot range is -180 to +180. Okay, like this. Okay, it will become a -180 to +180, and plot properties you can just control. By default, it will take -200 to +200. You can just, for example, if you want to plot only -90 to +90, like
Mm,
this, it will come. Okay, this is one
mm.
option. The second is like mm, oh, three-dimensional plot is not there. This is far field cuts, right? Uh, uh, oh, here, yeah. Again, it is having the. Mm, if you want to view far field, mm,
So, for example, our designed unit cell we have to simulate
uh-huh.
what we designed at this position. If we simulate this and finding the far field, let me show this.
Yeah, it's also fine, but it will be incomplete. Let's see. Mm, oh, everywhere the far field cuts. And also you can create a 2D formatter as well. Let's say H wheel, where you can see both H field as well as the surface current. What they have done is, they excited the phase for each antenna, and then they want to combine the results. It's like a, you can see here, this is the port one.
Mm.
You can animate and see also. You can see here, alternating current. You can see here, arrow
Mm.
changing, right? It
Right.
is like, uh, that's how it is. And if you want to see the 3D plot, mm, here, right? So it is same applies to 3D plot also. All structure transparent, right? Just remove. It will not be transparent, or you can just show transparent.
Mm.
And if you want to view the results with the uh, oh, this much time it is taking. We can stop this.
Yes, yes. Sir, after completely making this design, then we again take a meet to for the simulation results, sir.
Sorry.
Sir, I complete today or tomorrow. I will complete the design completely according to paper.
Yeah,
Uh, should we have again a meeting on maybe next Saturday for the simulations?
yeah, 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 no problem.
Mm. Thank you, thank you.
Okay, so the just the only thing is that you have to go to 3D plot, far
Yes,
field result. Then you will see the one option called show structure. You click, it will show the. Can you go to the paper?
yes.
It will show this bottom structure and also this pattern. That's it. Okay, very easy.
Okay,
Yeah, that's it.
okay.
Okay, then thank you. Yeah,
Sir, can you send me the
yeah, yeah,
record?
yeah. I will. Okay,
Okay, okay. Thank you,
thank
thank you,
you.
sir.